Hi, and welcome to this lecture on loops. In this lecture, we are going to learn about what loops are, for loops, while loops, the range function, list comprehensions, and some common errors associated with these. Okay, so let's get started in our script editor. Okay, so in your viewport, okay, hold down the space bar, go to panels, go down to panel, and fifth one from the bottom, the script editor. We can also close our channel box too, okay, by pressing this highlighted icon up here. All right, gives us a little bit of extra space. Okay. All right, so what are loops? Okay, let's get started right at the beginning. Loops are a way to repeatedly execute a block of code in Python. There are two types of loops in Python. There are for loops and there are while loops. Instead of other programming languages where loops are contained within brackets, Python uses indentation to indicate level and define your code. So this helps with the readability and forces you to write clear code, well, in most situations. Okay, so let's have a look at for loops. Okay, a for loop is used to iterate over a sequence of values. So as follows, the syntax for a for loop is for, and then we assign a variable to each one item of the sequence. So for variable in our sequence. Okay. All right, so when we're iterating over a sequence of values, these come in the form like a list or a tuple, but you can also iterate over dictionaries and sets as we've shown. Okay, so in this syntax, the variable is a temporary variable, which is assigned to each value in the sequence at one time. And the code inside the loop is executed once for each value in the sequence. So this variable can be anything we want. As we've shown, it can be I. It could stand for item or iteration. It can be num. Okay, if you know you've got a number coming forward, go for number in, say, numbers. Let's say you have a list called numbers that you could get called number. This can literally be anything you want. Okay. All right, but here's an example of a for loop that iterates over a list of numbers and prints each number. So we'll change this to, as we just said, num. I'm going to call this number. Oh, sorry, we'll call this the plural. Let's go with that. Use good grammar. So numbers. We'll create a list here. So we're going to go 1, 2, 3, 4, 5. Okay. And we are going to print. Here's our functionality. Okay, print, open parentheses, and num. Okay. All right, so we've got numbers. Okay. We again highlight it, hold down Control while it's highlighted, and then press Enter, and this will execute the code. Okay, storing numbers with the list 1, 2, 3, 4, 5 with all of those integers 1, 2, 3, 4, 5. So, and now we can run our loop again with our indentation, and we get 1, 2, 3, 4, and 5. Okay, straightforward. So let's now look at a for loop with a dictionary. Okay. So with the dictionary, it works as follows. So let's go with ages. So let's imagine we want to keep the ages of some employees. Okay, we've got Sam, who's 31, Sally, who's 26, Steve, who's 29. Okay, let's go again. We can iterate any name here, but for readability, within this, we're going to be getting the key when we loop through ages. So let's have a look and see what our output is. Okay, and here's what we've got. So let's have a little look at what we've done here. Let's clean out our window and actually reprint this. Okay, so we've got our code that's executed here. So here is our code. Okay, it's being printed out. And here is what our output is from that code. Okay, we've got, this is a key, Sam, and this is a value. So we've got our key value pairs being cycled through. So Sam, 31, Sally, 26, Steve, 29. Okay, so we see here, okay, we've got, this is a key. Okay, and we've got the key. And now, if you remember, okay, to access any index within a dictionary, we need the key. So we use our dictionary and we say we're going to use this index for this key within our dictionary, which then gives us the key. Okay, and then at the end, we're actually printing a new line. which is why we've got these spaces between each one of these prints. Okay, but we can also loop through tuples in a pair. So we have now got a list of tuples here. So we've got, okay, we've got a list. Okay, let's give a little bit of space for readability. Okay, we've got a tuple here with 1 and 10, 3 and 30, 5 and 50. Okay, so we could just print for tup in my pairs, which would give us this 1, 3, 5, 10, 30, 50. Okay, it just gives us back our tuple. It just prints it out. Or we can loop through the tuple, unpacking the items. Okay, like so. So we'll go with item 1, item 2, and then we can go item 1, item 2. Okay, so now we are printing through everything, okay, with its own, okay, with its own variable name, okay, assigned to each unpacked item within the tuple. So nice and straightforward. Okay, we've got item 1 and item 2. Essentially, it's going through all of our items and unpacking them because we have 2 items to unpack. This will give us an error if we have too many items to unpack. So yeah, and it actually gives us a very useful error if you see here. So we've got a value error, too many value errors to unpack, expected 2. Okay, it expected 2 because we've only got 2 variables here. It's helping us out even further by telling us what the problem is. Okay, if you didn't see this error, what I should have said, I forgot to say at the beginning, is remember you should have line numbers ticked on and show stack trace. If not, tick these both on and then rerun this piece of code and you should see these. Okay, so now that is everything we're looking at. Let's have a quick look actually at one more example. So we'll go, let's go my items. Let's give you one more functionality here. Okay, we're going to go my items 1, and we are going to go 1, 2, 3, 4, 5. And we are going to go with the exact same list, but we're going to change it slightly. And we are going to go with double everything. Okay, so now we've got 11, 22, 33, 44, and 55. Okay, how do we iterate through these 2 items? Let's say we want to get the item, okay, times 10. All right. Oh, well, not times 10. But, okay, let's just say, like we do, we want to get these items, okay, as we're showing here, okay, within this list, okay, matching up to the item that we have in items list 2. Okay, what we can do is we can actually use the zip functionality and we can unpack both of these items simultaneously to our variables item 1 and item 2. So now this zip will essentially, it takes any number. You could have 3, 4 lists of items. As long as you have the right number of variables down here to take them, you can unpack them to these variables. So we've got 2 lists. So we take 2 variables to unpack these items. And now look, as we print out, let's clear our output window. Okay, we are printing 1 and 11, 2 and 22, 3 and 33. Okay, 4, 44, 5 and 55. Okay, so essentially 11 times each one of these items. Okay, nice. Okay, that's called the zip functionality. You'll probably use that quite a lot. But let's also have a little look at something else. Let's go for, we'll keep items 1. What we're going to have a quick look at is the enumerate functionality. So what enumerate does, it gives us another little bit of functionality. So enumerate, okay, my item. So this has got our list here. Let's say we had a list of items that we also wanted to give ourselves. So let's say we had sphere, box, and we'll go ball. Okay, let's say we're going to iterate through our items, but what we do want, we actually want a number so that we can associate them or give them a number when we're naming them, or that we can print out which number we're going through within our list, again, to give the user some feedback. So what we could do is do this. So num and item 1. And let's have a look at what happens here. So we've printed our item. It's in the window. We've seen it. And now we're iterating through and we're going, oh, I didn't reinitiate. Here we go. My item's 1. Ooh, here we go. See, that was, again, a logical error. We're not going to get an error, or actually that would have given us a name error because an item 1 isn't defined if we were running through this all again. But what I've done there is I've not renamed my item. Okay, so let's actually rename that for clarity and call that item an item. So we're iterating through our list of items. Okay, let's name everything correctly. My items, and we're going to iterate through it, assigning the variable item, okay, to the items we're iterating through in the list. Okay, and there we go, perfect. Okay, 0 sphere, 1 box, 2 ball. Okay, it's giving us a nice little bit of feedback. So we're iterating through the list. But annoyingly, we're starting at 0. Okay, and if you remember, that is because we always start counting in Python at 0. So what we can do is, for readability, just do num plus 1. Okay, and that starts at 1 for us. Okay, a nice, easy way to work there. Okay, and that is the enumerate function. Definitely have a little look at this a bit more, because you will use enumerate and zip a lot as you start working more, even if it's just to say give yourself a list of items that are selected from the scene, and then have a list of names that you're going to associate, have a list of attributes that you want to assign. Okay, there's always going to be something that will need unzipping and then looping through within a window, okay, within the structure and the format that you have placed. Okay, great. So that is for loops. Let's move on. Let's go on to while loops. Let's also clear our output window up here. Okay, now while loops. A while loop is used to repeatedly execute a block of code as long as a certain condition is true. The syntax for a while loop is as follows. Okay, so while a condition, okay, and then code to be executed. So within here, you can print whatever, okay, but this will always print. This will continue forever until you either switch off the machine or this condition is met, okay? And we'll talk about that a little bit further on, but okay, so let's explain the syntax. So in this syntax, this condition is an expression, okay? This is evaluated before each iteration of the loop. If the condition is true, the code inside the loop will be executed, and the process will repeat until the condition becomes false. Here is an example of a while loop that prints the numbers 1 to 5. Let's go with, okay, I equals 1. We'll go 1. We'll put our little condition in here. So we'll go while equals 5. Okay, print I. Now, for those of you out there who know about while loops, we're missing something key in here that will stop us ever exiting our while loop. And that is changing the value of I. If we do not change the value of I, this will execute forever. Okay, so we need to make sure that within the loop, we have a parameter, or we have some functionality that changes the value of our variable that is being checked. Okay, so I plus equals 1. So now, as we go through this, every iteration will cause I to get 1 added to it. So first time it runs, we're going to check, and is I lower than or equal to 5? Yes, it's true, because it's still 1. Okay, it runs the code, adding 1, and then goes back to the start. Okay, well, what is I now? I is 2, so it'll run again, run through the code, add it again. So you have to make sure you're changing whatever the check is at the beginning of your loop. Okay, let's execute this code now. 1, 2, 3, 4, 5. Okay, brilliant, there we go. It is exited the code once I has become greater than or equal to 5, okay? So in this example, the loop starts with I set to 1. Okay, the loop condition checks if I is less than or equal to 5. Since I is initially 1, okay, the condition is true. So the code inside the loop is executed. The print statement prints the value of I, which is currently 1, okay, And then the I plus equals 1 statement increments by 1, okay? Now this will increment all the way up to 6, at which point the condition becomes false and the loop terminates. So it's going to terminate once it gets to 6, okay, printing out the first 5. While loops are useful when you need to execute a block of code repeatedly, but let's say you don't know how many times the code needs to be executed ahead of time. The condition can be any expression that evaluates to a Boolean value, true or false. So you can use a while loop to check a specific condition or to repeat a block of code until a certain criteria are met. Okay, so one thing to be careful of while using while loops is that the condition it's got to become false eventually. Otherwise, the loop will continue to execute, as we've already stated, indefinitely, leading to an infinite loop. And the problem with Maya is that Python is running within Maya. Okay, this isn't a separate IDE we are using or running. We're not running Python outside of Maya. This, if you set an infinite loop running within Maya, okay, this will cause your Maya to either crash, freeze, and essentially continue running this loop, using up all your memory. That's another option. I think it's got a lot better now with Python 5, but you can embed while loops within exit functions, okay, or functionality that you can press the escape button to. So I'd advise maybe doing that, or having the ability to exit out, or maybe always just having a limit, okay, set, because you don't want your while loop going up to 10 million. Okay, that's why I generally stay away from these within Maya, because it's very rarely that I need to run something indefinitely. Even if I do a for loop up to a range of 10,000, I know that at some point that criteria should be met, and I can put a break into the loop, which means, again, it's going to save me having any problems with a while loop. So there's just some issues to watch out for. So, okay, let's move on. The range function. So the range function can quickly generate integers for you, okay, based on a starting and an ending point. This can be useful when we want to build a series of joints in Maya, and the user has told us how many we need to pick. In this case, we can take that input variable that the user has given us, okay, and we can use that in the range function. So note, this is a generator. Okay, well, what's a generator? A generator is a special type of function that generates a sequence for you, a sequence of variables on the fly. Okay, or a sequence of values on the fly, I should say. So instead of returning them all at once, like a regular function. Okay, so let's make this into a little bit more of a loop. So for I in range 5, okay, we'll put our colon at the end. Remember, we've got to have our colon with a while loop and with a for loop. Okay, print I. There we go. So we're printing all the way up to 5. So that's 5 items, okay? Remember, we start counting at 0. Okay, if we wanted to start counting, if we wanted to do all numbers up to 5, then that we would just start at 1 within 1 Pythonically and go up to 6. Now we are going up and printing 1 to 5. Okay. We can set the start and end of a range similar to indexing and slicing that we learned about earlier. And that is done, as I've done here, by just putting the beginning point and the end point that we want to go to. Okay. Can also just print that out just to see what we're going to get if you're ever wanting to test what is going to happen within your code. Okay. And there we've printed the range. So we've got the generator. But now what we can do, we can print a list. Okay, this will turn our generator into a list so we can check it. And you see we get 1, 2, 3, 4, 5. Okay. So what we can also do is, like we said with indexing and slicing, we can add a step. So let's increase this amount to 20. Okay, so we're going to go from 1 to 20. And we're going to print every second item. So we're going 1, 3, 5, 7, 9, 11, etc. Okay, so you see ranges are quite useful for us, especially if you want to, say, build a controller system maybe on every other joint. Let's say, because, for example, in my spine rigs, I allow you to set how many joints you want within a spinal rig. Okay, and then I allow you to select how many controllers you have on there, or how many they're spaced out by. So using that information from the user, I then use this methodology here to go, well, the user has selected that they want, okay, 22 joints. So we just put in, well, 21. And then they say they actually want a controller every fourth one. So after I've created the joints, what I do is I say, well, these are the positions that our controllers are going to be spaced out on for the user. So you see a very easy way within Maya to kind of give yourself some user required information. Okay, and then select your joints, okay, these iterations, and build controllers on them. Okay, brilliant. So now let's move on to list comprehensions. All right, we've touched on these earlier, but again, I love these. Okay, these are great little snippets of code. And let's run into them in a little bit more detail. Okay, so if you cast your mind back, list comprehensions are a concise and readable way to create new lists, okay, in one line of code, and that can save us a huge amount of text or huge amount of typing. Okay, so let's start with this example. Okay, which I see can't even be bothered to type it all out. There's too much. Okay, but okay, we've got X, which is our list 1, 2, 3, 4, 5. We've got our new list, which is empty. Okay, and we're going to now cycle through an item. For each item in X, so we're assigning our variable to X, we are going to use our new list, and we're going to add to that new list item, okay, times, okay, squared. So nice and simple. But, okay, do we want to do it this way? I would say no, because this is quite a small amount of functionality. So written in a list comprehension, it's going to be much easier. Let's do that now. Okay, we've got everything above, but let's do this now here. So let's go new list. What am I doing? Sorry. Here we go. We'll open up our brackets and we'll go item star to, okay, for item in X. And so that is doing everything that is happening here. Okay, much easier. We should print that out. So what do we get from our new list? Okay. So our new list is 1, 4, 9, 16, 25. Okay, let's see what we get from our new list here. 1, 4, 9, 16, 25. So you see, we've done the exact same thing. Okay, but we've just reduced the code a lot. I would say an increased readability. Okay, so again, okay, just remember we can do some beautiful things that reduce code. Okay, and make Python much more readable, and that should be always your focus as you get better and as you improve. So list comprehension, it's a great tool, but remember it's not always appropriate for every situation. Don't sacrifice readability for a list comprehension, okay? In some circumstances, that might be the case, and that is what might happen, okay? In this circumstance, we've done the opposite, but there are circumstances where there are lots of variables, maybe lots of conditions, and lots of embedded loops that you don't want to do 2, 3 embedded loops or embedded list comprehensions with excess conditions with them, because now we're going to start talking about a line that gets longer and longer and longer until you're just making something very, very unfriendly to people to look at a glance. Okay, so you've got to remember that list comprehensions are a little bit faster, but they allocate more memory. So they shouldn't be seen as a golden bullet, okay? Now, most of the time, what we're doing in Maya shouldn't be too memory intensive. If it is, it means you should probably go back, read through your function, and try to clean it up, okay? Which we might go into a little bit later. But again, if you're writing good code, it shouldn't be an issue. So let's go through some examples of some list comprehensions, starting from beginner to advanced. Let's go through creating the squares of the numbers 1 to 5, as we've just done, okay? But so example 1, let's go example 1. All right, so we're now not going to use X, we're going to use range. Okay, we'll go from 1 to 5. So we're going to use our generator here. Okay, that gives us, okay, this item, this generator item, which we can now loop through on the fly. Okay, it's not stored anywhere. So this, again, the benefit of doing it this way is we do not have a variable now with the stored generator in it. We're actually saving ourselves some memory quite quickly. Okay, but what we are doing, again, is just increasing readability. So new list, equals, yeah, 149, 16, 25. Okay, nice and straightforward. Okay, let's create a list of even numbers from 1 to 10. All right, so let's go example 2. Let's call this evens. Okay, and we'll go open up our brackets, our square brackets, and go x for x in range. We'll go 1 to 11 if we're going to do 1 to 10. Okay, but this one we're going to have to put a little condition in there. We're going to go, okay, if x and our modulus operator, here we go. So x modulus operator, sorry, I got my mouse right in the way there. Okay, so, okay, divided by 2, leaving us the excess of 0, means that only even numbers, okay, will be accepted through here. Let's see what we get. Yeah, 2, 4, 6, 8, 10. All right, obvious. Okay, brilliant. All right, let's go for a third example. What do we want to do? Let's create a list of tuples containing a number and its square. Okay, so let's remove our condition. Okay, let's just go from 1 to 6. Okay, it will, again, anything we put here will be returned. So we can update this ourselves. We'll go for x and x times, or star 2, okay, squared. So essentially, what we're going to get is, yeah, 1 squared is 1, 2 squared is 2, 3 squared is 9, 4, 16, 5, 25, okay? Nice and quick. Again, we've got a generator giving us our numbers. We are then outputting them to a list, okay? But we are not storing this in our memory. So this will save us quite a bit of time if we have to do this a lot or multiple times. All right, let's do a fourth example. Let's do an example with some text. We'll go with word equals hello world, okay? And let's just say for some reason we only need the vowels, okay? So we'll go with char. And we'll go char for char. It's short for character, okay? We'll go for, should say words really, shouldn't we? Let's go with words. Okay, word, but it's definitely not right. We will now say, so if char in, and we will just print out all our vowels, okay? So A, E, I, O, and U. Or not, okay? Get a little, what happened there with my typing? Completely the wrong part of the board. Okay, so what do we get here? So we got E, O, and O. We've got a list of only the characters that are vowels. So any char or any car, I don't know how you want to say this, any character essentially that is in, okay, A, E, I, O, U. So we are cycling through every item, okay, within Hello World, and we're saying if that character is within this list here, okay, this is going to look at it, or sorry, it's within this string, which will be looked at as a list, then we'll say, oh, yeah, okay, yeah, allow it if it passes this condition. Okay. Let's go for one more. Let's try to use a bit more of an advanced method. Let's use numbers. So let's get even squares. So let's go for something a little bit more advanced. Okay, let me think. We'll use a filter, maybe in some mapping in this. Excuse me. So list comprehensions can be used to filter map elements as well. So let's say we've got a list which we've used to create, which has just a series of numbers in. Okay, and we've got the square numbers. Okay, let's go back. I'll see if I can, yeah, we'll put that code back that we had a minute ago. Okay, let's go back. Where is this code? I think I've got an idea in my head. Yep, so even squares. So squares. Let's go with even squares. Okay. Wait for it. The madness will reveal itself shortly. We'll go to 11, and then we'll say, well, if x modulus operator divided by 2 gives us a leftover of 0. We know it's even. So let's execute this. Even squares, we get 4, 16, 36, 64, and 100. Okay, that is only evaluated everything for any item that is even. So, okay, so the expression, okay, x star star 2 is the mapping function that squares each element. Okay, that is the way that we should probably look at this. Okay, so while the if causes, while the if essentially filters out any odd numbers, resulting in the list 4, 16, 36, 64, and 100, okay, which contains the squares of the even numbers 2, 4, 6, 8, and 10, okay? If you remember, we're going through our range here, 1 to 11, okay? We don't have a step, we're not going through the even numbers, which we could do, but here we're getting everything from 0 to 10, and then saying, okay, well, if it's even, okay, then, okay, give us the feedback, okay? All right, so we've got a little bit of mapping function here, and we've also got a filter occurring. This is another way of looking at the condition here. Okay, we could try and shorten this a little bit by giving ourselves, okay, another way of doing it. Let me see, we've gone for the wrong one here, so what we would need to start at is 0. And you see, we get 0, 4, 16, 36, 64, and 100. Again, only the even numbers, again, because we are setting what our range is here. Okay, 0, 2, 4, 6, 8, and 10. All right, let's go for another example. Sorry, I went back to 4 there. That was example 5. Okay, we'll now go on to one more example. So a list comprehension that maybe is nested inside another list comprehension. Okay, so we'll do a couple of these. So let's do nested as our naming here. Let's go with, again, simple 1 to 10. But let's say we want to now go for I for I in range. Okay, X. So, okay, this is going to give us a very large, well, not very large, a larger nested list. So, you see, we're now nesting, okay, one list comprehension inside another, which is what I was talking about earlier. You can just keep on nesting and just get a little bit crazy inside of this, and then we can go, well, and we can go O for O in range I. So you could start nesting this. Obviously, functionality doesn't just have to be range, but okay, this will give us everything within the range of this. So obviously where we started off as 0, well, there's no numbers up to 0. Okay, then we've gone to 1, so it's given us just the first, it's given us the Pythonic 1, which is 0, then the 2, which is 0, 1, and then the 3 items. So again, we've got a nested item. But let's look at maybe a more, a much more difficult kind of concept. Let's look at maybe a matrix C. Or okay, we're going to go with, okay, an outer set of brackets for the list, and then we're going to go with 1, 2, 3. And we're going to go with 4, 5, 6, 7, 8, and 9. Okay, so we've got our matrix here. Here we go. Okay, so a matrix, there we go. Again, highlight, press Command or Control and Enter. But now, what we can do, this is a very tough concept, okay? We're going to flatten this list. So if we wanted to put all of these items together, let's say you're cycling through a list and you're getting items, okay, in a list back, okay? Or you got that back from certain functionality. We can flatten this list by going, okay, X for X in row. Okay, so what we're getting here is we're going to go for row, okay, within matrix, and then X within row. So let's talk through this. Okay, in this example, we're using a nested list comprehension as we've done before, but this is creating a new list called flattened, okay, and that contains all the even numbers in the matrix list flattened into a single list. Okay, See, there, easy, nice. Okay, the outer loop is iterating over each row in the matrix list, okay? Resulting in the list containing all the numbers in the matrix list at the same level, okay? So then we're cycling through one item, but then the outer row, okay, is cycling through it again. Okay, so let's look through some common errors that can really easily happen, okay, with loops, as we've said about with the while loop. So infinite loops, okay, it's an infinite loop occurs when a loop condition is always true and the loop never terminates, okay? This can happen if the loop is not updated correctly or if there is no exit condition. An infinite loop can cause a program to hang or crash, and this is a common error with while loops, okay? So, off by one errors, okay? Yeah, very simple. Again, this error just occurs when the loop condition is not set correctly. So let's say you wanted the numbers from 1 to 10, but you set your range just with 10. Obviously, that's going to point from 0 to 9, not up to 10. Okay, so it's a very simple error. It's not, again, it's a logical error because Python won't crash. This is, again, you just need to read through your code and make sure you check your loop before running through it. Okay. So, and that can easily happen with while or for loops. But okay, let's have a look at the next one. So, unintended changes to the loop variable. This is easily done, okay? But again, shouldn't be. So, when you're looping through, okay, any variables, okay, or any chunk of code, you should reassign or create a new variable, okay, when you're going through it, rather than reassigning the variable you're looping with. So, if we're going for item in list, okay, we shouldn't now reassign that item, a variable, to anything else. We should maybe do new item if we're doing a newly named item with that list item, but we shouldn't overwrite the loop. Otherwise, later on in the loop, or later down in that chunk and block of code, you might need the original name and you have no way of using it now, okay? So, iterating over a changing sequence. Again, we've talked about this previously. Okay, if a sequence is being iterated over and changes are happening to the loop during its execution, it can cause unexpected behavior. For example, adding or removing elements from a list while iterating over it can cause a loop to skip or repeat elements. Okay, so again, make sure that you create a new list or a new item if you're looping through an object, okay, and creating it. Don't you append a list or a tuple, or don't append anything that you're using for the iterator of the list. Okay, create a new list, new tuple, new something. Okay, to work with. All right, nesting errors. Oh, again, easily done. Nesting errors can occur when loops are nested inside each other and the indentation is not set correctly. So, as we've spoken about previously, this can cause the loop to execute incorrectly or not at all. So to avoid these errors, it's essential to test your loops thoroughly. Make sure you print out what you're iterating through before setting it in stone, and to double check your code for logical errors, okay? Debugging tools like print statements and breakpoints can also be really useful in identifying and fixing loop errors, okay? So, for example, if I know I'm going to go through quite a long list, so for item in long list, okay, what I might do is I might, okay, try and break down the length of the list and just go up to 5. Okay, we know from this, if this long list is of 10,000 items, we don't want to test it by going through all 10,000 items. We just want to give it a print and then go item. Okay, another way is if I just want to print out or just do one iteration of the list, I can do a break. Okay, which again, after the first item is printed out, we'll now break out of this, okay? So remember, you've got all these abilities, which we're going to go into break and continues later. But again, this is just a quick example. Okay, so well done. In this video, we have learned about what are loops. We've learned about for loops, while loops, the range function, list comprehensions, common errors, and best coding practices essentially with these, okay? Thank you so much for listening, and I look forward to seeing you on our next video.